Important compounds of boron. In that, the first one is borax. Borax, the formula of the borax is Na2B4O7 10H2O. Na2B4O7 10H2O. Na is sodium, B is boron, O is oxygen. So 4 boron, tetra boron with oxygen, borate. Sodium tetra borate decahydrate 10H2O. Sodium tetraborate decahydrate is the chemical name, means the name of the borax. Okay, so this prepared by the colmanite ore. So as we discussed in earlier class about the colmanite ore or Ca2B4B6O11 treat with sodium carbonate Na2CO3 will be getting Na2B4O7 earlier what we discussed. And also this is prepared from boric acid H3BO3. Boric acid is also treated with H3BO3 is also treated with soda ash or Na2CO3 sodium carbonate will be getting Na2B4O7. So Na2B4O7 is called again as borax or sodium tetraborate decahydrate, and with the formation of liberation of carbon dioxide CO2 and H2. These are the two important methods, and it is white crystalline, and it is white crystalline solid. We earlier we discussed about this preparation and this property, which is a white crystalline solid. White crystalline solid, and in basic nature in aqueous solution in alkaline due to hydrolysis. So hydrolysis due to the presence of water Na2B4O7, which each are an hydrolysis due to the presence of H2O molecule will be forming NaOH and H3BO3. H3BO3 is called earlier method of preparation. We said no, orthoboric acid. Orthoboric acid, or simply it's familiarly known as boric acid or orthoboric acid. Okay, and which will be which also used means upon heating decomposition Na2B4O7 10H2O decomposition of borax. Borax on decomposition will give Na2B4O7 water molecule will be removed from this. So Na2B4O7 Na2B4O7 which on further heat which on further heating which gives NaBO2. NaBO2 is called sodium metaborate. Sodium metaborate, plus along with that with the formation of B2O3. B2O3 is called boric anhydride. Boric anhydride apart from moisture content. So OH content, OH group. So borax on decomposition gives Na2B4O7 means water molecule will lose, and after that the losing of H2O molecules it forms Na2B4O7. Further it heats to form 2 NaBO2. NaBO2 is called sodium metaborate along with the formation of B2O3, and this is used in a borax is used as water softener and the cleaning agent, which will be used in cleaning agent. In laboratory, borax is used as qualitative and quantitative analysis, especially borax bead test. Borax bead test. So borax, the transparent glassy beads, okay, is brought into a contact with some colored salts like what metaborate. So what it will be, the B2O3. B2O3 is boric anhydride. Boric anhydride or like bead like structure means the beads. It is like the beads. This will be treated with the metal borides. Metal borate. This will be treated with metal oxides, anhydrous anhydrous boric boric anhydride is treat with metal oxides, especially transition metal like nickel oxide or Cr2O3, chromium oxide or cupric oxide or etc. This will be treat with boric anhydride treat with nickel oxide will be forming the nickel metaborate NiBO2 twice nickel metaborate, which is the brown color, which is brown color, which is brown in color. So how it will be formed? Colored metaborate will be forming, colored metaborates will be forming. So this is the test we call as borax bead test. Borax bead test. Characteristics color beads or characteristics metaborates will be forming brown color. So chromium react with anhydrous boric or boric anhydride will be forming the green color chromium metaborate. So green color. Similarly, copper react with the B2O3, which gives a blue color cupric metaborate. Blue color cupric metaborate. Similarly, cobalt, capital C, small o, and oxide, oxygen, capital O. Cobalt oxide treat with B2O3 will be forming cobalt metaborate. That is also blue color, but that is dark blue, navy blue. And the manganese oxide, MnO, manganese oxide treat with B2O3, which gives manganese metaborate MnBO2 twice, that is pink color. So this is how we can able to identify the metals, especially transition metals in metal borate form, which gives the color. This is known as borax bead test. Borax bead test. So when we, how will be getting this? The mixture of sodium metaborate. Earlier we said no, Na2, yes, NaBO2 plus B2O3. NaBO2 sodium metaborate plus B2O3 borax oxide. Together we known as borax bead, transparent beads. This will be treated with respective metallic oxide, then which gives a characteristics color. From that we can able to identify the respective element. So same when borax is also treated with alcohol like ethyl alcohol C2H5OH and a little amount of concentrated H2SO4, H2SO4, then which burns in the flame gives green color or green edge flame, green edge flame. This is the test used to identify borate, test for borate. So qualitative and quantitative analysis. So this will be used. Borax. First compound is borax. Clear? Next, orthoboric acid. Orthoboric acid, familiarly known as boric acid, H3BO3 or BO3. Okay, HBOH thrice, H3BO3 or BOH thrice, boric acid or orthoboric acid. How it will be prepared? By the acidified or acidification of aqueous solution of borax can be prepared. Sodium metaborate Na2B4O7 treat with hydrochloric acid HCl, right? Hydrochloric acid means HCl, saturated solution of HCl dissolves in water will be forming HCl solution. This will be treated with sodium metaborate will be forming boric acid. And the sodium metaborate treated with sulfuric acid H2SO4 means H2SO4 in solution water. So solution of H2SO4 will be forming boric acid, orthoboric acid. Orthoboric acid, it is also prepared from colmanite ore, which is also prepared by colemanite ore or colmanite ore. You know that calcium ore, that is Ca2B6O11 treat with okay SO2, sulfur dioxide SO2 H2O, acidified sulfur dioxide, which gives CaHSO3, calcium bisulfite, CaHSO3, SO3 is sulfide, H is hydrogen, calcium bisulfite, PHIT, calcium bisulfite, along with the formation of H3BO3, H3BO3, that is orthoboric acid or boric acid. So it can be prepared by the acidified solution or acidification of egg-based solution of HCl and or H2SO4 from treated with borax. Okay, borax can be prepared by acidification solution of borax. Borax is treated with acidified solution. Both sulfuric acid and hydrochloric acid will be getting H3BO3. Okay, and from the hydrolysis of boron compound. So example BCl3 from hydrolysis boron trichloride BCl3 treat with water H2 will be getting H3BO3 H3BO3 with the liberation of hydrochloric acid. So there's another method of preparation of boric acid, means hydrolysis of the boron halides BCl3 or Bn. This also can be prepared boron nitride Bn on hydrolysis H2O give rise to H3BO3 boric acid plus NH3 ammonia. This is how in a number of methods. So boric acid or orthoboric acid can be prepared. Are you getting? Next, what are its property? So boric acid is a crystalline solid and soapy touch. Soft and soapy touch is exactly slippery like sodium hydroxide. Slippery like sodium hydroxide. Boric acid is crystalline solid, right? Crystalline solid and soapy touch, soft and soapy touch, and it is sparingly soluble in cold water, fairly soluble in hot water, or sparingly partial soluble in cold water. Okay, and it is a weak monobasic acid, weak weak monobasic acid. Okay, and it will be treated with the water if the orthoboric acid H3BO3. So if it is treated with water H2O, treat with water will be forming the boric iodide, so BO84 minus. Similarly, treat with the sodium hydroxide NaOH will be forming NaBO2, sodium metaborate. Okay, and upon heating at higher temperature, when we heat boric acid, means orthoboric acid H3BO3 at heat decomposition at high temperature will be forming HBO2 metaboric acid plus water H2O. HBO2 is called metaboric acid. Metaboric acid. Okay, so these are the properties of the orthoboric acid and the uses. What are the uses and the structure, how it will be structured? Boric acid used in food preservative. Boric acid used in the food preservatives and is a mild antiseptic. Mild antiseptic. Hence, it will be used in eye wash. Have you heard about eye wash? What you are using? The solution that is boric lotion, boric lotion or boric solution, the same as eye wash, and it is used in the manufacture of the borax. It is also used in the manufacture of borax. Earlier method we saw now the preparation of borax which will be used, and so and we know that and transparent coating, layer of transparent coating, that is the preparation of the glazes or enamels in pottery. In pottery, we know that which will be glazed. but okay, will be shining. That can be done with the treating of the borax. So these are the uses. And the boric acid structure will be having, so boron hydrogen, boron oxygen, oxygen and hydrogen. So I hope I'll be having slides that we'll see if it is slide okay. Otherwise, I'll write. So physical properties of boron is boric acid, sparingly soluble, crystalline, soapy touch. Okay, next structure uses manufacture in the heat resistance, borosilicate glazes. Borosilicate glaze, glaze means shining article, and preservative of food and stuff manufactured in enamels and glazing potteries used as eye wash, major important. Okay, there's a structure of the boric acid. The structure of boric acid. Here, the boron, oxygen, oxygen, oxygen. There's OH and OH. Okay, so H3. What is the boric acid? Any the boric acid form orthoboric acid H3BO3. H3BO3. Okay, so ಎಲ್ಲಿ sir hydrogen no H3BO3 ಅಂದ್ರೆ ಅಲ್ವಾ? So here H3BO3 what it will be closed structure ನಿಮಗೆ ಹೇಗೆ ಕಾಣುತ್ತಾ ಇದೋ, so it look like benzene ನೋಡಿ, here inside, here and here is look like the benzene structure. Okay, but that's not benzene, need not to get worried. We'll be having the bonding. Okay, so H3BO3 boric acid. So uses, preparation, property, and the uses of boric acid. Are you getting? So not only this boric acid, we need to study about the diboron. That is important. One of the important the compound we need to study about diboron. So this is borax. Okay. Next, diboron. Diboron, you heard this earlier in previous chapter also. B2H6 is called diboron. Diboron is a series of compound of boron with hydrogen. Series of compound, because B2H6, B4H10 and B5H11, the plenty of compound will be getting. The series of compound will be getting the boron treated with hydrogen is known as boranes. Simply boron and hydrogen long chain compound now will be called as borane. Diborane is prepared by the reduction of boron's trifluoride BF3 with lithium aluminium hydride. Okay, lithium aluminium hydride in presence of diethyl ether will be getting C2H6. C2H6. This is familiarly known as laboratory method of preparation of diborane. Laboratory method of preparation, in laboratory method of preparation of diborane, okay, is prepared by the oxidation of sodium borohydride with iodine. So in iodine, industrial method of preparation, on industrial scale, diborane is prepared with BF3 and sodium hydride. Okay, these two methods, this boron treated with boron trifluoride BF3, okay, treated with sodium hydride, okay, NaH sodium hydride. That is an industrial scale, large scale of preparation. So that is the not have given the equations or not, I don't know. So that is how it will be. So 2NaBH4, two molecules with treat with an iodine will be forming B2H6 plus sodium iodide, NaI plus H2. So equation is not good. So we'll be writing, so NaBH4, NaBH4. So that is sodium borohydride treat with iodine I2, okay, which gives in presence of polyether will be forming B2H6 sodium iodide NaI with liberation of hydrogen gas. This is the industrial method of preparation. And this will be, so sodium borohydride treat with B2H6 and NaI industrial method, and this B2H6 with treating with lithium aluminum hydride in laboratory method. Here only that equation. Huh? Okay. So here is the equation and the laboratory method of preparation. So these two methods you need to remember. Okay. In industrial scale, diboron is prepared with boron trifluoride. Okay. So BF3 with lithium hydride. This also can be prepared with lithium hydride. Boron trifluoride means boron halide is treated with lithium hydride, LiH, okay, will be getting at higher temperature, roughly 450 Kelvin, will be getting B2H6 diborane with the formation of lithium fluoride. So that is B2H6. Yeah. Yes, sir. This equation, diborane, how the diborane is prepared, boron trifluoride treated with one of the powerful reducing agent, lithium aluminum hydride. Okay, is lithium aluminum hydride, this Li and Li lithium plus combines with fluoride to form lithium fluoride, and boron with combines to form boron dihydride B2H6 or diborane, and aluminium combines with fluoride to form aluminium fluoride AlF3. That is laboratory method. Small amount of diborane is prepared. But in the case of industrial preparation, sodium borohydride treated with iodine will be forming B2H6 diborane. That is an laboratory method. As well as in industrial method is also prepared, okay, in large scale by hydride, usually with hydride, boron trifluoride treat with lithium hydride. So we'll be forming B2H6 and lithium fluoride. Okay, lithium fluoride and B2H6 boron hydride will be forming. So boron hydride is called borane, especially B2H6. We'll be discussing about B2H6. Okay. So diborane is a colorless, highly toxic gas. Colorless, highly toxic gas, and which will be boils at 180 Kelvin. So S boron trifluoride and 6NaH sodium hydride or lithium hydride will be getting B2H6. So both are industrial methods of preparation. So what is this? This is a structure. This is a structure of the diborane B2H6. So B2H6 we need to study about the important factor here. One of the important question usually will be getting 3 center 2 electron or 2 center 3 electron, and based on this. So diborane is colorless, highly toxic, right? And boils at 180 Kelvin and the melts at 108 Kelvin. It is an electron deficient compound. You know that act as a Lewis acid, electron deficient. Yes, this is what you said as banana bonding visual. Yeah. Next, this diborane catches fire spontaneously upon exposing to air. Upon exposing to air, it catches fire. It burns oxygen, releasing an enormous amount of energy. So B2O3, formation of B2O3 from B2H6. So B2H6 is diborane, no? B2H6. Treat with oxygen, O2 will be forming B2O3. B2O3. So anhydride, yes, yeah. This is we studied where you studied earlier. Anhydrous boric anhydride that is B2O3. Okay, B2O3, and with the formation of water, with the formation of water H2O. So this one, this diborane, these are the physical properties B2H6. Boron, hydrogen, boron. This is very familiarly called as banana bonding. Banana bonding. This is here. Boron, hydrogen, boron. Hydrogen is in rigid position. Rigid hydrogen. That is what we call as banana bonding. How it will be shares with each other. How it will be sharing. Okay. And especially for this B2H6 is banana bonding. B2H6 non-planar molecule. In B2H6, boron undergoes an sp3 hybridization. sp3 hybridization, which has 4 normal 2c2 electron, 2 centered 2 electron bond. 1, 2, 3, 4. 4 normal, 2 centered. Here electron and electron, 2 centered 2 electron bond. Okay. This will be boron hydrogen BH bond. These are equivalent bonds. The sharing of an electron, and will be present in the same plane. If we consider like this, will be in the same plane. Here will be in the same plane. But as like the boron and hydrogen, in few of the 2 bonds, the two bonds of here, this first one and second one, will be having bridged hydrogen. Boron, hydrogen, boron. This is bridged hydrogen. This is what we call as banana bonds. And this is we call as one and one. Here, the two electron. Here and here, two electron. These two electron binds together, one, two, and three center. So these two are known as three center two electron system. Three centered two electron system. That is what we call as BHP bond. And there's a banana bond which lies above and below. What we consider, if it is in the plane and above is a bridging and below will be the bridging. If the rest of boron, hydrogen, hydrogen, and here boron, hydrogen, and hydrogen, that will be in the plane. This is bridged hydrogen, and here is a bridged hydrogen. There's already, the banana bonding. So the three center, two electron of four bonds, and the three center, two electron of the two bonds above and below, which is present above and below in the plane. Okay, that is B2H6 diborane, one of the important compound. In that, one important question, very, very important question will be noticing here. In the chemical reactivity, boron react with nitrogen will be forming. So, will be forming one important compound is called borosine. Important compound is called borosine. Borosine is very famously known as inorganic benzene B3N3H6. B3N3H6 is called borosine. So physical property, diborane is a colorless, highly toxic, boiling point 180 Kelvin, and biborane catches fire spontaneously on exposing to air. Diboranes are highly spontaneous flame towards a flame in air. Chemical property. In chemical property, they react with water to form boron hydroxide B2, this H3BO3 boric acid with the liberation of hydrogen gas. It bonds with oxygen, evolves an enormous amount of energy with forming boric anhydride. And the reaction with Lewis base, it cleavage undergoes the cleavage reaction, separation of the compound will be forming BH3, B2 half of the compound gets separated, one carbonyl group attached to that will be forming the additional compound, Lewis base to form adductor compound. When diborane react with ammonia will form benzene, is called inorganic benzene, that is important compound you need to remember. When treat with diborane B2H6, when B2H6 treat with ammonia NH3. So upon heating, diammoniated diborane intermediate, and finally we'll be getting B3N3H6. B3N3H6 with the liberation of hydrogen gas H2. Okay, so this is called inorganic benzene. This is called borosole or borosine. Borosine or borosole is called inorganic benzene. Inorganic benzene. So the structure of this is exactly like benzene. Exactly like benzene. Just 1 minute. Yes. So this is the structure. Boron, nitrogen, boron, nitrogen, boron. Alternator. Like carbon and hydrogen will be having C6H6. C6H6. Like B3N3. 1, 2, 3, 4, 5, 6. That is 6 hydrogen. B3N3H6. This is called borosine. Very important. You have to remember. Are you getting? So you need to remember this diborane B2H6. Okay, in that B2H6, how it will be diborane, and in the case of the borosine. So both the structure is important to you. Okay, are you getting? As like aluminum, as like as like aluminum. So we need to know about the group 13 elements of aluminum. Sorry, as like boron, we need to know about aluminum. So we notice that always the co-upping reactions, always what it will be forms. Okay, means how they react similar air or oxygen or water, or they react with alkalis, or they react with acids, or etc. Okay, in one of the compound, just you have to remember, one of the compound is potash alum. Potash alum. So that is important. Anhydrous aluminum chloride of the compound, few compounds are important. That is AlCl3, anhydrous aluminum chloride. So anhydrous aluminum chloride, we know that aluminum react with the chlorine to form AlCl3. Okay, aluminum chloride. Anhydrous aluminum chloride is used as catalyst in Friedel-Crafts reaction. Friedel-Crafts reaction. Okay, and the manufacture of gasoline, or the boiling fractions of, to hide the boiling fractions of petroleum, this will be using anhydrous aluminum chloride, or it is used in the manufacture of gasoline. So cracking, to separate the petroleum product, this aluminum chloride will be using, anhydrous aluminum chloride will be using. Anhydrous aluminum chloride is also used in the manufacture of the perfumes, drugs. Okay, drugs or perfumes or dyes. Okay, that will be used in perfumes, dyes and drugs. AlCl3 have it can able to prepare aluminum chloride or hydrated AlCl3, treat with water to form hydrated aluminum chloride. Aluminum treat with hydrochloric acid or treat with chlorine will be forming aluminum chloride, AlCl3. Okay, anhydrous remove moisture content, AlCl3, AlOH tries will be there, or Al aluminum means apart from moisture content, anhydrous aluminum chloride will be used as catalyst in Friedel-Crafts reaction, will be used as the drugs and dyes and perfume used in the manufacture of gasolines. Okay, next potash alum. Potash alum, that is K2SO4, K2SO4, Al2SO4 thrice, K2SO4, Al2SO4 thrice, 24H2O. That is called potash alum. Potash alum. Okay, what is the formula of potash alum? K2SO4, K2SO4, Al2SO4 thrice, and 24H2O. This is potash alum. Potash alum is prepared from the bauxite Al2O3, treat with sulfuric acid. Okay, and it will be used, where it will be used majorly, it is used in the cleaning action of water. Okay, it is used in the cleaning agent, means potash alum. You heard about alum. Potash alum is used in purification of water purification, which is used mainly it will be used, and it is used in the dyeing coloring agent. It is used as antiseptic for the arrest of bleeding, to avoid the bleeding, which will be act as antiseptic. And in leather industry, so in tanning in leather industry, so which will be used potash alum, or potassium aluminum sulfate. Potassium aluminum sulfate, that is a product of from the bauxite or from aluminum. Yes. Yes, white crystal. Alum is white crystal. You can see transparent crystal, that is that keep in a water for the purification, means to remove the impurity which will be used. Okay, this is about the group 13. So we need to study about group 14. Okay, group 14, carbon family. So I hope last one, potash alum used in the heating of, means in the manufacturing of the shoes, slipper, that is we called as the tanning of leather. Okay, means to modify leather, we need to heat that, we need to treat with the chemicals. So for the cleansing action means the heating of tanning of leather will be used. This alum, potash alum will be used. Okay, purification of water it will be used, and antiseptic, and to arrest bleeding, to avoid bleeding will be using uh, potash alum K2SO4 Al2SO4 24H2O. Okay, are you getting? Next, we need to study about group 14. So group 14, I hope afternoon or some other time I'll take class, afternoon or evening. So I'll take class and we'll finish that. Okay.